Hello, today we're going to go over polyatomic anions and how we can memorize their formulas and names. A polyatomic anion is something that's negatively charged, that's the definition of anion, and it is composed of many atoms. So everything below is going to have more than one atom, and it's going to have a negative charge. So what we have first is listed by their group on the periodic table. These are the ions with 4 oxygens in them. So you'll see everything has O4 as the second part. The first part is made up of one of the nonmetals from the periodic table. So we have phosphorus, sulfur, chlorine, bromine, and iodine. Each have polyatomic anions that have 4 oxygen atoms in them. So what we want to do is see what do these guys have in common. You can see right away, we already said they're made of a nonmetal plus 4 oxygens, and hopefully you notice that there's a pattern in their charges. So right here, we start in group 15, which has a 3- charge. It's not going to be the same down here, so be careful. But when we go over 1, it's a -2, and then this last group, the halogens, group 17 on the periodic table, they all have a -1 charge in their polyatomic anions. So that's a pattern we're going to see repeating here in a second. What about when we compare these ions that have 4 oxygens to the counterparts down below that have 3 oxygens now? So if I'm comparing sulfate, which was SO4 2-, to the one down here with 3, it's named sulfite. So one of the tricks that I want you guys to remember is that 8 ions, that means the ones that end with the ATE ending, like phosphate, sulfate, or nitrate even. 8 ions have one more oxygen than 8 ions. Okay, so if I'm comparing sulfate to sulfite, 8 has one more oxygen than 8. Okay, so let's go down here and talk about the 3 oxygen polyatomic ions. And we have some, like borate has 3 oxygens. So you can't say that all of the 8s have 4 or all of the 8s have 3 because it varies. Sometimes it's 4 oxygens in the 8 ions and sometimes there are only 3. Okay, but we do have another trick for that in a second. So borate is BO3, 3-. Carbonate and silicate have 3 oxygens and a 2- charge. And then here's the tricky part. Remember up here, this phosphate had a 3-, and phosphite also has a 3-, but nitrite right above it is NO3 -1. Okay, so that has a different charge than the one right below it. And sulfite has the same charge as sulfate. And then we had perchlorate, perbromate, and periodate in group 17 up here with 4 oxygens. And down here, we drop the per. So chlorate, bromate, and iodate have 1 less oxygen than their per 8 counterparts. Okay, so per blank 8, and the blank is any of the halogens. We can put perchlorate or perbromate or periodate in there. Per 8 has 1 more oxygen than the 8 ion. Okay, then 8 ions. And notice that the only per ions are in the halogen group. Okay, they're the only ones. If we go down here, there aren't any other per 8 ions. Okay, and then scrolling down, these are ions that have 2 oxygens only. So I have nitrite, which is NO2, compared to nitrate up above, which had 3 oxygens. Nitrite is NO2-. Okay, so the charge stays the same and you're just going down by 1 oxygen because 8 has one more oxygen than ite. Okay, chlorite is ClO2. So from chlorate to chlorite, you lose an oxygen. Same with bromite and iodite. Okay, so those are not too hard. And hypochlorite, hypobromite, and hypoiodite, just like we only had per 8 ions for the halogens, only the halogens have hypoite ions. Hypoite, so hypochlorite, hypobromite, and hypoiodite, hypoite ions have just one oxygen with the halogen that it's combined with. So chlorine, oxygen, -1 charge. Bromine, oxygen, -1. And iodine with oxygen and a -1 charge. Okay, so those are the hypoites. And then down here, we have some that we're going to have to come back to and memorize. Okay, so these ones are kind of the weird ones at the bottom that don't have a nice pattern in the periodic table like the ones up above do. So we're going to come back to these other ions in a second. Going back up here, an easy way to remember all of these, everything on this list, is to memorize the 8 ions. Okay, so if we memorize the 8 ions, then we can know the rest just by remembering the pattern of 8 has one more than ite, per 8 has one more than the 8, and hypoite, they have just one oxygen. So if we remember the rules and we memorize all of the ions that end with ATE, then we will know a lot of them. Okay, so how do I memorize the 8 ions? I'm going to teach you guys a trick. Down here I have the periodic table, and the ones that we are talking about were in group 13, 14, 15, 16, and 17. So the halogens, and we actually don't worry about these bottom two down here, and we don't usually worry about fluorine when we're talking about polyatomic ions. It doesn't have any that we use frequently, okay? And the ones that we're going to use are in kind of a T shape right here. Okay, so these ones and these ones, including tellurium. Okay, and then these halogens right here that I did not cross out. So there is a little mnemonic that's going to help us with this. You can see that we have halogens, those are the yellow. We have some just nonmetals, that's the green. The green is just other nonmetals. And then we have a couple of the, or a few, of the metalloids or semimetals. We have boron, silicon, arsenic, and tellurium in some of our ions. And all of them are being bonded with oxygen. Okay, so he's like the special star of the polyatomic ions. Down here where hopefully we can see a little bit better, and I'm going to zoom in just a tad. Okay, I'm going to outline the T group. Okay, the T group right here in green. These are going to be lumped together because they all behave similarly. Okay, so that's my T group. And I'm going to use purple for the 4 group. It kind of looks like a 4. Okay, and then the 3 group, T43. I'm going to use blue for these last 3 right here. Okay, and I'm going to go ahead and color these in. So I wanted you to see the elements, but let's make it more transparent so we can highlight. Okay, so we have these halogens. They are part of the 3 group. The 4 I have all of these guys right here. Let me highlight them in purple. Okay, and can you see the 4 shape right there? Okay, so the 4 and the 3 and the T group, these elements right here make up the T group. So we have this little T, and I'm going to do it in black. Change transparency. Okay, so all together we call this T43. Okay, and the T43 is a little trick to help us remember all of the 8 ions. Okay, so we're going to put these elements with oxygen, and they're all going to end with ATE, okay, or 8. So down here in the T group, boron, carbon, nitrogen, and silicon, those all have 3 oxygens. So I'm going to add O3 onto each one of those. Okay, and their charges make a pattern, just like we saw up above. We have 3 minus, 2 minus, and -1. And right below carbon, silicon also has 2 minus. Okay, and that's the T group. The 4 is phosphorus to arsenic and sulfur down to tellurium. Those all have 4 oxygens. PO4, SO4, SeO4, ASO4, and TeO4. And then the pattern starts over, but in this group. So under nitrate, it's not a -1. We start over in the 4 group. So a 3 minus, 2 minus, and this we haven't got to yet, but those are going to be -1. And right below them, same pattern. 3 minus, 2 minus, and below selenium, tellurium also has a 2 minus charge. Okay, and the last group, this is the 3 group, which is kind of weird. It's not really a 3, it's more like a 1. But the 3, where you're touching the chlorine, bromine, and iodine, tells you how many oxygens there are in chlorate, bromate, and iodate. So there are 3. So O3, O3, and O3. And then they all have a -1 charge underneath the chlorine, and down they're all -1. Okay, so what are these things that we just made? Boron is borate. Carbon is carbonate. Okay, so you just use the root of that element and add an ATE ending to show how many oxygens it has. So we have borate, carbonate, nitrate, and silicate. Those are part of the T group, which we highlighted up here. And the green T group, those all have 3. So T equals 3 oxygens. The 4 group right here, these guys, those all have 4 oxygens. And then our 3 group, we're back to 3 oxygens again. And their charges go -3, -2, and -1. And then the pattern starts over again. -3, -2, and -1. And then below them, they continue. So below the -2 would be -2. Below this one would be 3 -2, -2, and these are all -1. Okay, so hopefully that helps you memorize all of the 8 ions, from borate all the way down to iodate, and how many oxygens and what charges they have. And then we're going to remember, once we've memorized these ions with our T43 chart, the ite ions. So if I come back here, I've memorized all of the 8. So I memorized chlorate is ClO3 minus. Chlorite is just 1 less oxygen than chlorate. Same thing with sulfite. If I memorize sulfate is part of the 4 group, so it's SO4 2 minus. Sulfite is SO3 2 minus. Okay, so I hope that really helps you guys in studying your polyatomic ions. The only way to get really good at them is to practice. So go on Quizlet, do the games that they have. There are many polyatomic ion sets on there, so use that to study. And I also gave you guys one before the break with a little game, so you guys can do those. These other ions that end with 8, there isn't a real trick to them. You just kind of have to study and memorize them. Hexafluorosilicate. Hexafluoro means 6 fluorines. And silicate, notice these three are the only weirdos that end with ATE. Actually, I lied, not this one. These two are the only weirdos that end with ATE and do not contain oxygen. So hexafluorosilicate is silicon with 6 fluorines and a -2 charge. Thio means sulfur containing, and cyanate, Cn- down here, this is a pretty common ion, is cyanide, which you want to stay away from, Cn-. And thiocyanate is cyanide with a sulfur attached to it. Oxalate, I kind of remember because they're all evens. So I have 2 carbons, 4 oxygens, and a -2 charge. Acetate is a very familiar ion because it's in vinegar, and we use vinegar a lot in chemistry and at home when we're cooking and making food. So acetate, also sometimes called chiku, is CH3COO-. Okay, so there are 3 hydrogens around this carbon bonded to another carbon, which is then bonded to 2 oxygens next to it. And the reason it's written kind of weird is because it's telling us that structure. Chromate, that's chromium plus oxygen, so it's CrO4 2-. Dichromate is like if you had 2 of them, so it's Cr2O7. There is 1 less oxygen than we think there should be. Like if we doubled the O4, it should be O8 because the 2 chromiums would be stuck together, so you lose an oxygen. Same charge. Manganate is MnO4 2-. Permanganate, MnO4 negative. Okay, cyanide we already said, Cn-. Hydroxide is a base, and that's going to be really important later, so we have to memorize hydroxide, OH-. Hydrogen and oxygen, and it's negative, so hydroxide. Peroxide is O2 2-. Remember the prefix bi for some reason means a hydrogen in there. So bicarbonate is one we talked about in class. That's HCO3-. So it's carbonate with a hydrogen stuck to it. Okay, I hope that helps you guys study, and please email me if you have any questions at all. Have a wonderful day.